Okay, so let's get right into it. We're going to go way beyond the marketing hype and really demystify what's actually inside these massive AI models that are, completely changing our world.
It's the big question, right? You type something into a chat box and you get this incredibly smart, coherent answer back. But what is happening under the hood? I mean, what kind of machinery is actually at work to make that happen? Well, the first thing we have to do is get rid of one big myth. The popular idea of a single, all-knowing digital brain? That's completely wrong. It's a great sci-fi idea, but it is not the engineering reality. Not even close. A much, much better way to think about it is as a hidden factory. Yeah, a massive, super complex, industrial-scale operation. And today, we're basically going to take you on a tour of that factory. We are opening up the black box. So, like any good factory, this one has some secret ingredients, right? For these frontier AI labs, we're talking about advanced engineering techniques that give them their edge. Let's start by digging into a couple of the most important ones they don't really talk about. First up is something called synthetic data flywheels. Now, here's the crazy part. Labs have basically run out of high-quality human data on the internet. So what do? Well, you get the AI to create its own training data. And this creates an incredibly powerful, self-improving loop. And check this out. This is how it works. A really strong model generates, let's say, a super complex math problem. Then another model tries to solve it. An automated system checks if the answer is actually right, and if it is, bingo. That whole conversation gets added to the training data for the next generation of models. It's literally a machine that teaches itself how to get smarter. Okay, technique number 2 is a huge architectural secret. Mixture of experts, or MO for short. Instead of trying to build one single, impossibly gigantic model, you build a team of smaller, specialized networks. You can think of it like having a committee of specialists instead of one really overworked generalist. Now, the magic here is this little thing called a router. When you send in a prompt, this router looks at every little piece of it and says, okay, this part here is about Python code, so that goes to experts 3 and 9. But this part is about Roman history, so that goes to experts 7 and 12. This makes the model ridiculously efficient and lets it scale to a massive size without just grinding to a complete halt. So these individual techniques, they're kind of like the specialized machines on the factory floor. But how do they all fit together? Well, they combine to build what the industry insiders call the AI Superstack. So again, forget the idea of a single model. Frontier AI is a skyscraper. It's a massive, multi-layered structure where every single floor totally depends on the one below it just to function. And here it is. This is the blueprint for that hidden factory. A 12-layer superstock that shows you exactly how you get from raw silicon and hardware at the very bottom all the way up to autonomous agents at the very top. This is the real architecture of AI today. I know, 12 layers looks like a lot, but you can actually group them into 3 main zones to make it way easier to understand. The bottom is your core infrastructure, that's the raw power and the basic model. The middle section is all about intelligence refinement, where the model gets smarter, safer, and more knowledgeable. And that top section, that's the autonomous frontier, where the AI starts to learn how to act on its own. Building a skyscraper like this, as you can imagine, is not easy. And it is definitely not cheap. So now that we've seen the machinery, let's talk about the absolutely immense cost of actually running this factory. Here's the thing. Only a handful of companies on Earth can build these systems from scratch. And why is that? Well, it's because of what people in the industry call the AI Trinity. You need 3 things, and you need them in absolutely massive quantities: mind-boggling compute power, web-scale proprietary data, and the very small group of elite researchers who know how to glue it all together. And just how much compute are we talking about? Well, the estimated cost for a single training run of a next-gen model is now over $1 billion. Yeah, this is not a game for startups anymore. And to spend that $1 billion, you need the hardware. We are talking about colossal GPU clusters, sometimes with up to 50,000 of the latest NVIDIA H100 chips, each one of those costing about as much as a new car. And what do you feed those 50,000 GPUs? Data. Trillions and trillions of words, images, and snippets of code, which we call tokens. The sheer scale of data you need is a huge barrier all by itself. So all of this leads to this huge gap between the public story and the actual reality inside the industry. We're told that AI is just getting smarter and smarter exponentially, but the labs know they're hitting a scaling wall where they're getting diminishing returns. We're told our data is safe and encrypted, but the reality is our prompts often become training logs for future models.
So, if just making the models bigger and bigger is starting to hit a wall, where does the industry go next? Well, the focus is shifting from just building a bigger factory to building a factory that can upgrade itself. And this is what's called the autonomous frontier. I mean, we're talking about AI that creates its own data to get smarter. We're talking about AI that acts like a research scientist on its own. And get this, even AI that can design the very neural networks that will eventually replace it. So, if you take away one thing from all this, it's this. The next great leap in AI isn't going to come from just adding more GPUs or more data. It's going to come from making the system itself autonomous. A huge shift from manual engineering to automated self-improvement. And that leaves us with one final, pretty profound question. For years, we've struggled to just understand what's inside the black box. But what happens when that box gains the ability to design and rebuild itself? What comes out of it then?